Welcome to this video where we're going to explore a crucial concept in computer graphics and geometry processing, finding the sign distance of a vertex. This topic might seem niche, but it has far-reaching implications in various fields, such as game development, architectural visualization, and scientific simulation. The sign distance of a vertex is essential for many algorithms that involve mesh manipulation, physics-based rendering, and collision detection. In this video, we'll delve into the details of how to calculate the sign distance of a vertex efficiently and accurately. We'll break down complex concepts into simpler parts, using examples and analogies to help you understand the material better. By the end of this video, you'll have a solid grasp of the performant and correct way of finding sign distances. To start with, let's define what we mean by the sign distance of a vertex. In simple terms, it's the shortest distance from a vertex to a reference plane or surface, taking into account the direction of the normal vector. The sign of the distance indicates whether the vertex is in front of or behind the reference surface. Now, there are several approaches to calculating the sign distance of a vertex. Well, some methods involve using explicit equations for specific shapes like planes, spheres, or cylinders. However, these approaches can become cumbersome and impractical when dealing with complex geometries. A more robust method involves utilizing the concept of barycentric coordinates. By expressing a point in terms of its proximity to the vertices of a triangle, we can efficiently compute the sign distance using simple arithmetic operations. This approach is particularly useful when working with polygonal meshes. Another key aspect to consider is the orientation of the reference surface. Depending on whether the normal vector points towards or away from the viewer, the sign of the distance may need to be adjusted accordingly. It's essential to ensure consistency in the calculation to avoid incorrect results. Let's use an analogy to help illustrate this concept. Imagine you're standing in front of a mirror. If you take a step forward, your reflection appears closer to you. However, if you take a step backward, your reflection seems farther away. The sign distance is similar. It depends on the direction of the normal vector and whether you're moving towards or away from the reference surface. To summarize, finding the sign distance of a vertex involves 1. Understanding the concept of barycentric coordinates and how they relate to proximity. 2. Considering the orientation of the reference surface and adjusting the sign accordingly. 3. Utilizing efficient arithmetic operations to compute the sign distance. These key aspects are crucial for accurate calculations, especially when dealing with complex geometries. In finding the sign distance of a vertex is a fundamental concept in computer graphics and geometry processing. By grasping this concept, you'll be better equipped to tackle more advanced topics like mesh manipulation and physics-based rendering. We hope you found this video informative and engaging. If you have any questions or would like further clarification on any of the points discussed, please leave a comment below. Don't forget to like this video and subscribe for more content on computer graphics and related topics. What's your favorite use case for sign distances? Share with us in the comments.